going to discuss topic 5, the absolute value function. Our essential question is, what are the key features of the graph of the absolute value function? And by the end of this video, you will be able to analyze functions that include absolute value expressions. Absolute value functions. F of x equals the absolute value of x. So we have these bars surrounding x. Those are our absolute value bars. Absolute value is the distance from 0 on a number line. It's always positive outcomes, and the graph looks like a V. So again, distance, you're always traveling, is going to be positive. So remember, absolute value is distance from 0, always going to be positive. This is a key fact to remember. The graph will look like a V as such. Axis of symmetry. It's a vertical line that goes through the vertex that splits the graph into symmetrical halves. What that means is it splits it in half, meaning the distance over here is going to be the same distance to the middle line as it is on the other side. So this axis of symmetry cuts the V right down the middle. The vertex is this point where it kind of changes directions. It's that middle point. For absolute value of x, it's going to be 0, 0. Reminder to pause the video at any time as you need to catch up with your notes. Complete the table and graph the parent function. So the parent function, f of x equals absolute value of x. If we go to evaluate and I plug in my x value, so I plug in the absolute value of -2, absolute value of -2 is going to be +2 because distance traveled to get to -2 is 2 units. Absolute value -1 will be 1, 0, 0. Absolute value of 1 is 1, and the absolute value of 2 is 2. If we write that as an ordered pair, meaning this is my x value, this is my y value, we have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. If we need to graph this, so graphing this starting with -2, 2, remember if we start at 0, 0, we go x value -2, y value +2. And there's our first point. Then we go -1, 1, and 0, 0, 1, 1, and 2, 2. And we can draw our lines to make this absolute value parent function. The domain, remember the domain is, okay, what about the x values? Is it going to the left forever? Yes, it is. So it's traveling to -infinity. And if you think the arrow is also going to the right, it's going to hit all the x values to the right as well, which means it's traveling to +infinity. So our domain's kind of those all real numbers. The range, we think, okay, these arrows are going up, but they're not going down. So we have a bottom of the graph here at 0, and 0 is included, so we need this bracket feature, remember. And it goes up forever, which means it's going to +infinity. The axis of symmetry. Axis of symmetry is that line that cuts it in half. The x value here is 0, so it's the line x equals 0. And the vertex is this point right here in the middle at 0, 0. Graph each function on your graphing calculator. So if you need the graphing calculator, there's a link in your Canvas page. If I open up Desmo's graphing calculator, you can type in using the keyboard here. You can also, if you hit Shift and the button above the return key is the absolute value. You see a vertical bar? You can type it in as such. And I'll go back to the graph. I took a screenshot of this to help us for our graphing purposes, to identify the domain, the range, the axis of symmetry, and the vertex. We're just identifying these things from this graph. So the domain, again, it's going left and right, so it's going to go to -infinity and +infinity. The range is going to be very similar to our parent. We look at the bottom of the graph. The y value here is 0. So 0 is included, so we need the bracket, and it goes to +infinity. We can use our parenthesis. The axis of symmetry, we think, what is the x value that it's going right down the middle? It's at 4. So the axis of symmetry is going to be x equals 4. And the vertex is sitting right over here at 4, 0. Let's go to the next one. So again, you can use your link to type in 2 times the absolute value of x. I included our parent function here so that you can see, okay, if we have a 2 in front of it, you'll notice that the graph is kind of compressing. Those y values are growing faster when we have that multiplier in front. So the blue graph is what we're trying to identify the domain, range, axis of symmetry, and vertex. The red graph is the parent graph. You can kind of ignore that for now. So blue graph, the domain is going to be that negative infinity to positive infinity. The range is going to be at 0, going to positive infinity. The axis of symmetry, it's going right down the middle, so x equals 0. And the vertex is at 0, 0. Again, you can go to Desmos to graph this. We have the negative absolute value of x plus 5. Here is that graph. The domain, it's going to be negative infinity to positive infinity. It's going left and right. The range, this is where it changes. See how the top of our graph is 5 and it goes down to negative infinity? So when the graph is upside down, it's going to go to negative infinity, and we need to list the top of where it stops. The y value here is 5, and 5 is included, so we need the bracket instead of parentheses. The axis of symmetry, right down the middle, x equals 0, and the vertex is sitting at 0, 5. Jay is biking to a checkpoint, then biking back to where he started. The graph shows the entire trip there and back. I want you to notice that this x-axis is talking about our time spent biking, where the y-axis is the distance traveled. So if this is where Jay starts, he bikes to a checkpoint. So it takes him an hour and a half to get there. And the distance he traveled was 45 miles. Now he keeps going for another hour and a half, and it gets him back to where he started, which was 45 miles away. So how far did Jay travel round trip? He traveled 90 meters. Maybe it's not miles, in meters. What are the domain and range of this function? Remember, there are stopping. There's no arrows on these. So be reminded of that there's no arrows of these, so this is not going to go off to infinity. So the domain, when you think of your x values, it goes from over here at the left, the x value here is 0. The x value on the right is 3. So it's between 0 and 3. It's included at 0, included at 3, so we have our brackets. Same thing for our range. We'll use our brackets. And at the bottom, the y value is 0, so the range is between 0 and 45. Find the slope between t equals 2 and t equals 2.5. So time, t is standing for the time of 2 hours and 2.5 hours. To find his speed in miles per hour. So 2 hours, this is where Jay was. Here he is at 2.5 hours. To calculate the slope, we need the rise over run. So if we count from 15 up to 30, he travels 15 meters in half an hour. So to calculate our rise over run, our y, change in y, that vertical change of 15 meters divided by our change in x, at half an hour, we get that Jay is traveling 30 miles per hour. Could be meters. This might be a typo, should have said meters. What does it mean when the graph is decreasing, increasing? Well, when the graph is decreasing, Jay is traveling from his starting point to his checkpoint. And when the graph is increasing, so going in a positive direction, J is traveling from the checkpoint to the point at where he started.